Good morning, everyone. Welcome to Software Engineering. I'm Zhang Shuang from Software College, Northeastern University. In this lecture, we are going to learn testing during object-oriented analysis. Here is an example of a CRC class for elevator controller. Class name, elevator controller, and its responsibility, including turn on elevator button, turn off elevator button, turn on floor button, turn off floor button, move elevator up one floor, move elevator down one floor, open doors, close doors, check requests, update requests, and so on. And the collaboration may need class elevator button, floor button, elevator, and so on. So let's check it carefully. For example, turn on elevator button. Now the class is elevator controller, and the controller is supposed to turn on elevator button. Is it true or not? What I would say is that this is totally unacceptable for object-oriented paradigm, because responsibility-driven design is ignored. Because button on or off, how to on and how to off is not the responsibility of the elevator controller. It should be the responsibility of button itself. So if the elevator turn on elevator button, information hiding is also ignored, because the implementation detail of turn on a button should be hidden within the button. So actually, turn on elevator button should be send message to elevator button to turn itself on. Actually, this problem is caused by overlooking a class, elevator door. Elevator doors have a state that changes during execution, open or close, right? So that is class characteristics. So we find that actually we should add one more class, elevator door. If a component in question possesses a state that will be changed during execution of the implementation, then it probably should be modeled as a class. So the class model should be reconsidered. And if the class model is reconsidered, the dynamic model and the use case model should also be reconsidered. So the second iteration of CRC class for elevator controller should be like this. Class elevator controller, and the responsibility. First, send message to elevator button to turn on button. Second, send message to elevator button to turn off button. 3. Send message to floor button to turn on button. 4. Send message to floor button to turn off button. 5th, send message to elevator to move up one floor. And 6th, send message to elevator button to move down one floor. And 7th, send message to elevator doors to open. And 9th, send message to elevator doors to close after timeout, and so on. So now this responsibility is more reasonable. This is the real object-oriented paradigm. And the collaboration classes includes elevator button, floor button, elevator doors, and elevator. So after this testing, the class diagram should be changed like this. Button is the base class, and it is derived by elevator button and floor button. Elevator controller will control elevator button, control floor button, and also control elevator doors. Since there are n elevators, there are n elevator doors. And the attributes of elevator doors is doors open. It's open or closed, so it's Boolean. So now the second iteration of the normal scenario for elevator problem should be described in this way. First, user A presses the up floor button at floor 3 to request the elevator. User A wishes to go to floor 7. Second, The floor button informs the elevator controller that the flow button has been pushed. Third, the elevator controller sends a message to the up flow button to turn itself on. Fourth, the elevator controller sends a series of messages to the elevator to move itself up to floor 3. And the elevator contains user B who has entered the elevator at floor 1 and pressed the elevator button for floor 9. So the elevator controller sends a message to the up floor button to turn itself off. So you see that now the scenario also changed. So far we have achieved use case diagrams, class diagrams, and state diagrams. So that means all 3 models are now fine. But we should rather say that all 3 models are fine for now. That means we may need to turn the object-oriented analysis phase during the object-oriented design phase if something is found wrong during the next phase. Developers should go back to OA to check it and to modify it. So that's why we say that all 3 models are fine for now. Case tools for OA phase. So far we find that diagrams play a major role in OOA because so far we have achieved quite a lot of diagrams. So we need some tools to help us to achieve the diagrams and to modify the diagrams because the diagrams often change. So we need a diagramming tool, and actually many tools go further. Almost all modern tools support UML, such as Rules by IBM, Visual by Microsoft, or MatrixJAW, and so on. You can just choose whatever tools that you prefer. Okay, so much for testing during OOA.